Our project is Comparative Performance Analysis of Petrol and LPG Engine. We have done our project in Greece Cotton Limited. Abstract. This project evaluated an experimental investigation on LPG as an alternate fuel for four-stroke spark ignition engine. The primary objective of the project was to determine the performance of the engine using different fuels. The engine used in the study was originally a single-cylinder four-stroke spark ignition engine at full throttling position of the engine at compression ratio 6:1, and minor modifications were carried out to permit the experiment to run on LPG fuel. During the running, the engine was coupled to eddy current dynamometer to measure the several engine parameters such as torque, brake power, fuel consumption rate, volumetric efficiency, and brake thermal efficiency. Introduction. With the increasing need to preserve fuel stock and minimize exhaust emission in vehicle application, many researches were carried out to improve the current combustion technology. One of the ways is to promote the use of alternative fuels such as natural gas, LPG, and hydrogen. LPG are the byproduct of natural gas production and refineries, and they are widely used in commercial vehicles. LPG has a higher octane number than gasoline, and it has higher latent heat of vaporization, which can reduce the compression pressure and temperature. It has lower stoichiometric fuel-air ratio and density compared to gasoline, and therefore it could reduce the specific fuel consumption and exhaust emissions. Moreover, when LPG is used in vehicle application, carbon dioxide engine note emission is reduced due to lower carbon molecule content compared to gasoline and diesel. In terms of performance, a higher thermal efficiency and improved fuel economy were reported from IC engine running on LPG. A higher octane rating for LPG make it safe to run in higher compression ratio engine without the occurrence of detonation, and subsequently the engine efficiency increases. Octane number is a numerical representation of the ability of the fuel to resist knocking when ignited in the cylinder of an internal combustion engine. This is the comparison of properties of petrol and LPG engine. Density for LPG is 0.5 kJ per kilogram. Specific gravity is 0.5 on 0.69 to 0.79 for gasoline. Boiling point of LPG is minus 42 degrees Celsius and gasoline is 100 to 400. Flash point. Flash point of LPG is minus 104 degrees Celsius and gasoline is minus 43 degrees Celsius. Specific heat for LPG is 2.4 kg per kilogram Kelvin and for gasoline is 2 kg kilogram per Kelvin. Lower heating value for LPG is 46,100 kg per kilogram and for gasoline is 43,000 kilojoule per kg. Lower heating value is nothing but the calorific value, which is the amount of heat produced by the fuel. Auto ignition temperature for LPG is 457 degrees Celsius and for gasoline is 257 degrees Celsius. Stoichiometric air fuel ratio for LPG is 15.7 and gasoline is 14.7. Upper and lower flammability limit in air is 74.5 and 4.1 for LPG and 7.6 and 1.3 for gasoline. Research octane number is 1 and 2 for LPG and 88 to 100 for gasoline. Motor octane number for LPG is 97 and gasoline is 80 to 90. Flame speed is 48 meter per second for LPG and for gasoline is 52 to 58. Performance analysis of a petrol engine. Introduction. Gasoline is a transparent petroleum derived liquid that is used primarily as a fuel in the internal combustion engine. It consists mostly of organic compounds obtained by fractional distillation of petroleum enhanced with a variety of additives. This is the composition of gasoline fuel, which contains carbon, hydrogen, nitrogen, oxygen, sulfur, and metals. This is the specification of the petrol engine, which we have calculated the performance parameters. This is the pictorial representation of the petrol engine. Basic layout of a petrol engine. The working of petrol engine is air from the atmosphere is enters into the carburetor where the fuel and carburetor mixes and it passes through the inlet valve and reaches the cylinder, and spark is produced through the spark plug and the power is obtained by the piston and cylinder. The power can be obtained from the crankshaft and the exhaust can remove through the exhaust valve. This is the experimental setup of petrol engine. where petrol engine is coupled to the electrical dynamometer to measure the basic parameters. Test procedure. The 4-stroke spark ignition engine used in the study has a displacement of 2-level CC and a compression ratio of 6:1. It is a single-cylinder, naturally aspirated, forced air-cooled with a bowl-in piston combustion chamber and equipped with a cylinder overhead camshaft. The test rig used in this work mainly consists of engine, eddy current dynamometer. The test engine was mounted onto a bed to facilitate the installation of eddy current dynamometer. The engine was coupled to eddy current dynamometer using a connector. The performance of the engine running on gasoline was basically determined from data obtained from the dynamometer. The eddy current dynamometer permits different load measurement in this study. The experiment was conducted for 3 trials in order to know the performance of engine in different conditions. Eddy current dynamometer. Eddy current dynamometer is based on eddy current, Fleming's law of right hand. It has a disc which is driven by a prime mover and magnetic poles are located outside of it with a gap. The coil which exits the magnetic pole is wound in circumference direction. When a current runs through the exiting coil, a magnetic flux loop is formed around the exiting coil through the stator and rotor. The rotation of rotor produces density difference, then eddy current goes to stator. The electromagnetic force is applied in opposite of the rotation direction by product of the eddy current and vector of magnetic flux, and it became brake. This is the test report of petrol engine. The speed of the engine is 3600, which is rated RPM, and the torque obtained by the engine is 6.84 in 47.2 seconds, that is for 25 cc. The power of the engine is 22.58 in kilowatt and 3.46 in HP. The specific fuel consumption is 575.69 grams per kilowatt hour. The fuel consumption rate is 1.4853 kg per hour and brake power is 2.58 kilowatt. The brake consumption rate is 575.69 grams per kilowatt hour and the air consumption is 4.951 into 10 to the power minus 3 meter square per second, and the volumetric efficiency for gasoline is 77.96% and the brake thermal efficiency is 14.542%. LPG engine. LPG is used as a fuel for engine. The sophisticated type of spark plugs are used to ignite the fuel in a cyclic process, and mechanical energy produced during the process is used to run the vehicle. Composition of LPG: propane 28.70%, butane 69.97%, and pentane 1.22%. This is the basic layout of liquefied petroleum gas engine. Modifications to be made. Some minor modifications have to be carried out in petrol engine to permit the engine to run in LPG fuel. The same petrol engine is modified into LPG engine by attaching an adapter before the carburetor and the inlet gas nozzle is mounted in between the air filter and carburetor. The gas flows from the LPG storage tank to vaporizer through the regulator. The various parts of the LPG engine are vaporizer, adapter, regulator, and LPG storage tank. Vaporizer: it is a control device meant to reduce LPG pressure and to vaporize it for regular flow of gas to the engine. Its solenoid valve controls the inlet by not allowing the LPG to enter the vaporizer when the engine does not need it. A slow idling adjustment for fine-tuning works as a check for the vaporizer, helping the vehicle with an instant and efficient start of the engine. The vacuum vaporizer ensures better control and regulation of the LPG pressure by vaporizing LPG from liquid to gas state. It is best suited to carbureted engine which work on the principle of vacuum generated in the engine. This is a pictorial representation of vaporizer, adapter, and LPG kit. Adapter. During suction, it creates a negative pressure which causes the solenoid valve to release LPG. It helps in supply of LPG only at required condition. A tube is connected in between the vaporizer and the adapter to provide vacuum such the gas flows from the vaporizer. As the suction created will make the diaphragm to lift, making the gas to flow to the inlet manifold of the engine. Regulator. Regulator is mainly used in switching on and switching off the gas supply. This is the representation of the LPG engine which is adapted with the vaporizer, adapter, and regulator. This is the experimental test bed setup for calculating the performance of the LPG engine. Performance test report of LPG engine. The speed at which the engine runs is 3600, which is the rated RPM, and the torque is 6.5 Newton meter, and the fuel consumption is 900. The power produced by the engine is 2.45 kilowatt, and in HP it is 3.285. The specific fuel consumption in grams per kilowatt hour is 361.22. The fuel consumption rate is 0.885 kilojoule per hour. Brake power is 2.45 kilowatt. Brake consumption rate is 361.224 grams per kilowatt hour. Air consumption is 3.1506 into 10 to the power minus 10 meters cube per second. Volumetric efficiency is 49.62% and brake thermal efficiency is 21.62%. Advantages of LPG. LPG has higher octane number of about 112, which enables higher compression ratio to be employed and gives more thermal efficiency. Due to gaseous nature of LPG, fuel distribution between cylinders is improved and smoother acceleration and idling performance is achieved. Fuel consumption is also better. Engine life is increased for LPG as cylinder bore wear is reduced and combustion chamber and spark plug deposits are reduced. LPG operation increases durability of engine and life of exhaust system is introduced. LPG has lower carbon content than gasoline or diesel and produces less CO2, which plays a major role in global warming during combustion. Disadvantages of LPG. As LPG is stored under pressure, LPG tank is heavier and requires more space than gasoline tank. There is reduction in power output for LPG operation and gasoline operation. Starting load on the battery for an LPG engine is higher than gasoline engine due to higher ignition system energy required. LPG system requires more safety in case of leakage. LPG has a tendency to accumulate near the ground as it is heavier than air. This is hazardous as it may catch fire. Future scope for advancement. In this performance analysis of engine, fuel with gasoline and LPG, both the engines are operated at the same compression ratio. When the engine is fueled with LPG, there was a 5% loss in brake power, which is mainly due to their volumetric efficiency. Major modifications have to be done in the cylinder head to reduce the clearance volume. As the clearance volume decreases, there will be increase in compression ratio. When the LPG engine is operated at a higher compression ratio, it will yield higher brake power and thermal efficiency without the occurrence of knock, which is mainly due to their higher octane rating. Conclusion. Thus, the analysis of petrol and LPG engine in terms of the brake power, torque, fuel consumption rate, brake consumption rate, volumetric efficiency, and brake thermal efficiency were done. As per the brake power is considered, there was 5% loss in power for LPG engine. This is mainly due to the reduction in the volumetric efficiency. As per fuel consumption rate is considered, fuel consumption rate of petrol is slightly higher than LPG. When the engine is fueled with LPG, fuel consumption rate is better than 37 to 40% of fuel is saved. The use of LPG in internal combustion engine yielded higher thermal efficiency and better fuel economy compared to unleaded gasoline. This is due to mainly the higher octane rating, which permits greater engine compression ratio without the occurrence of knock. Brake thermal efficiency is found to be set as high for LPG engine.